So rather than talking about the entire unit circle at once, we're going to start with finding the coordinates in just the first quadrant. Okay. We're talking about finding coordinates in just that first quadrant. All right. So again, the unit circle, before we kind of get started on those coordinates though, okay, I kind of wanted to find that word unit circle, right? We talk about this thing, the unit circle. Why is it called the unit circle? What's so special about it? And really all it is, again, mathematicians are not very creative in their naming. They just are very, you know, oops, it's a circle centered at the origin with a radius of 1. Okay, that's it. Unit, right, for 1. Unit means, you know, unit is 1. So unit circle, a circle with a radius of 1 that's centered at the origin. Okay, it doesn't have to be a circle with a center of 1. We could do this for a circle with a radius of any, you know, radius that we want, but it just is more helpful to have, you know, it have be a radius of 1 just for ease of calculations and stuff like that. Also, it's helpful to be centered at the origin because, again, our angles, well, the vertex of all those angles are at the origin. So again, it's just helpful to have that circle at the origin rather than at some other point because, you know, just the origin is easier to do. Okay. So, let's take a look here, and let's consider our unit circle in a big kind of picture sense here. So, some coordinates on our unit circle, we already know what those will be. Now that we know the unit circle means it's a radius of 1, okay, we have these points right here, for example. So this point right here, which is at you know, the 0 degree or 0 radian, okay, location, or 360 degrees or 2 pi radians, okay, what would the coordinate of that point have to be? Yeah, 1, 0, right? How do you know that, Zoe? Because you did it last year? Yeah. You don't know why? Well, it's a unit circle. So if we're going from the center of the circle, which is at the point 0, 0, and we're going 1 out, yeah, the radius is 1, so you're just going out 1 point. So that's really why it's 1, 0. Okay, that's really why. Okay, how about this point up here? What's the coordinate of this point right here, where we have the pi over 2 or 90 degree angle? What would that coordinate be? No, not quite. Again, think about it. We're going from the center of the circle up to the edge. Yeah, this point. Yeah, not the next one. Just what's, because we're, yeah, I'm kind of skipping some. I'm going to do the easy ones first. What would this be? You got an idea? Yeah, 0, 1. 0, 1, right? It's a 0. It's on the y-axis, okay? And it's got a y coordinate of 1 and an x coordinate of 0. Okay, how about this point right here, where it's 180 degrees or pi? What would this coordinate be here? Negative 1, 0. Negative 1, 0. Right, we're left 1 on upper down. And how about this last point down here? That'd be 0, negative 1. Again, that's at the 270 degrees or the 3 pi over 2. All right, so we already have an idea about some of the coordinates there. But then, of course, right, there's those other points. And Zoe already kind of mentioned the one here. So, you know, what? So the first point that's not on the axes here that we get to is this guy right here. And that's from the pi over 6 angle, or the 30 degree angle there. And we want to try and find the coordinates of this point. Okay, it'll be some x, y coordinate here. But of course, this one's harder to evaluate because it's not horizontally 1, you know, it's not horizontally 1 over, it's not horizontal or vertically 1 up or anything like that. It's at a diagonal distance there. Now we know the distance from the center to this point is going to be 1, right? Because that's a radius. This is another radius of our circle right here. Right, so you know that distance is going to be 1, but that's not an x or a y coordinate. That's like the distance from the center of the circle, and it's no longer a horizontal or vertical distance, it's a diagonal distance. So what can we do here? Well, the x coordinate, if we think about this, right, the x coordinate is going to be some distance here, x, horizontally, right, to about that point right there, just below the the point. But then y will be some kind of vertical distance off of that x-axis, like so. Okay, I'm kind of squeezing things in there, but there it is. So we have x and y. But by kind of now labeling our diagram this way, showing that x and y, we've created what kind of shape within that unit circle? A triangle. And not just any kind of triangle, but what kind of triangle here? A right triangle, and not just any right triangle, but if that's pi over 6 or 30 degrees, what's this angle going to be? So it's a 30, 60, 90, it's a special right triangle with a hypotenuse of 1, okay? So let's kind of pull that out here. Okay, I'm going to kind of redraw this triangle a little bit bigger. So now I have this right triangle, hypotenuse of 1 because of the unit circle radius there, some unknown x value, and some unknown y value there for the height. We know that our angle here is pi over 6, or again, if you want to say, you can say 30 degrees. Okay. And again, the vertex here is located at the point 0, 0. The vertex here, that's what we're trying to find. This is some x comma y, or I should do it this way. Some coordinate we're trying to find. That's our goal, is to find that point. X comma y. Okay. Well, yesterday we saw how to solve right triangles, right, using sine, cosine, and tangent, or secant, cosecant, cotangent, to get these missing values. So let's solve for x here first, right? Let's find that x value. So we're going to use our angle here, 30 degrees. What is x in relation to that 30 degree or pi over 6 angle? What is x? It's the adjacent leg, right? And then what is this 1 right here? It's the hypotenuse. So what trig ratio should we use? Cosine, right? We should use cosine to find this x value. So cosine of pi over 6 or 30 degrees, whichever you want to write in there, and I'm going to put pi over 6, okay? That should equal adjacent leg x over hypotenuse 1. But really, since the hypotenuse is 1, then it's really just the cosine of pi over 6 is the x value there. Okay? And so if we want to, we can type into our calculators cosine pi over 6 and hit enter, and we get x is approximately 0.866. X is approximately 0.866. But remember, I showed you guys that there's relationships. There's the relationships between the sides in a 30, 60, 90 triangle. So that x that's approximately 0.866 is actually exactly the square root of 3 over 2. Okay, it's exactly the square root of 3 over 2. Again, just to remind you, right, let me see if I can, I'll be able to fit that in there. I'll hold off on it. Okay, but it's a square root of 3 over 2. Maybe I'll draw it on the board up here. Right, that special right triangle. Okay, this is the 30 degree or pi over 6, and that's the 60 degree angle. Then hypotenuse would be 2a, the short leg would be a, and then a square root of 3. Okay, so in this case, our hypotenuse is 1. So then the a is 1/2, right? If that's 1, then it's 1/2 here, and 1/2 times the square root of 3 is root 3 over 2. Okay? Now, how can we go about finding the y? What trig ratio should we use to find y in this case? Sine. Yeah, sine. Okay, so sine of pi over 6, or 30 degrees, is opposite leg y over hypotenuse 1. Which really then, sine is simply just pi over 6 is equal to y. So y is the same thing as the sine of pi over 6. And so what is the sine of pi over 6? 0.5, or just 1/2. Okay. So we're able to evaluate then that the x-coordinate here will be the square root of 3 over 2, and the y-coordinate is going to be 1/2. And so we can kind of fill that in over here too if we want to. Square root of 3 over 2 1/2. Okay? Wow, we got a point with a ton of work. All right, that was quite painful, but there it is. All right, we were able to come up with that coordinate. We only have 2 more in this quadrant, and then 3 more in each one of the other quadrants, right? But we're not going to do all that work for all of them. We'll finish off the first quadrant. Okay, and then we'll show you how to do the second, third, and fourth. But there they are. Okay, those are the coordinates.
So at what point did you describe the line?
So we found the coordinate here on the unit circle that is 60 degrees, or sorry, 60 pi over 6, or 30 degrees, you know, up from the up around the unit circle there. Okay, the angle there that we open up to that point. Okay. So from that information, we now know that. Well, actually, I'll hold off on that. Never mind. We'll hold off on that. So let's try and find the next coordinate. Okay, which is at pi over 4 there, right? So I'm gonna take a different. I don't think I'll be able to squeeze it in there. So the next thing, let me see if I can do it. Yeah, we'll do it this way. So we'll draw. I'm going to focus mostly on the first quadrant here, so I'm only going to draw part of the unit circle. Okay, and we'll do the pi over 4, or 45 degree angle. Okay. And again, we know the hypotenuse of this triangle for the 45 degree angle. The hypotenuse is going to be what length? It's got to be 1, right? It's a unit circle, so we're talking about a distance of 1. There's the center of our circle there, right? It's going to kind of like continue on. But there's the center of our circle right there, so it's going to go a distance of 1. And so we've got this right triangle. And again, we want to find those coordinates. Some x coordinate here, some y coordinate here. What are they, right? Well, let's label this x and y here. And so what trig ratio could we use here to find x? Do you want to use tangent? Do you want to use sine? Do you want to use cosine? Which one do we want to use here to find x? Well, here's pi over 4. What is x in relation to that angle there, pi over 4? Adjacent, okay? And then we have the hypotenuse, so what trig ratio do we want to use? Cosine, again, right? Cosine of pi over 4 equals x. Right. Cosine of pi over 4 as a decimal, I think, is like 0.707. Whoop. 0.707 approximately. Okay. But exactly, it's the square root of 2 over 2. Okay, square root of 2 over 2. Okay. It is exactly the square root of 2 over 2. And then what about for y? How can we find y here? What trig ratio could we use? Yes, James. Yes, yeah, exactly. It's also because it's a 45, 45, 90 triangle that you're going to have the root 2 over 2 there, yeah. Yeah. But yeah, for then the y value, we're going to use sine. But of course, since this is a 45, 45, 90 triangle, if we know the x value is going to be square root of 2 over 2, what does that mean the y value has to be? Root 2 over 2, right? Because it's an isosceles triangle. So if this is root 2 over 2, that's also going to be root 2 over 2. But we'll just, you know, kind of show it here. If you do, again, the sine of pi over 4, let me do it with my buttons there. It's going to be the 0.707 again, which would then mean that y is also the square root of 2 over 2. Okay? And so we get the square root of 2 over 2, the square root of 2 over 2. Okay. Now we got one more angle in that first quadrant. But the good news is there's not really any more work to do for it. We've already kind of like we've done what we needed to do here. That last angle, pi over 3. Whoops, I don't know why I'm writing that there. Or 60 degrees. All right, again, the radius of the unit circle is 1, so the hypotenuse will be 1. Okay, and we want to find, again, the x coordinate here, and then the y coordinate here. And the calculation will be exactly the same. We're going to use cosine of pi over 3, okay, to get us the x over 1, which is just going to be x. And so our x coordinate here is going to be cosine of pi over 3. All right, what is the cosine of pi over 3? Well, it's 1/2. Okay, you type into your calculator. So our x coordinate here is 1/2. And then the sine of pi over 3, that's going to be our y, because again, sine is opposite, so the opposite leg there is y over the hypotenuse of 1, so it's just y. And so y is going to be approximately that 0.866 again, which we know is the same thing as the square root of 3 over 2. Okay, so square root of 3 over 2. All right. So this is how you derive, this is how you get the coordinates for that first quadrant. Okay, so how are we going to use this? What's the purpose of this? Why do we go through all that work? Well, because when you guys are kind of like on your own trying to evaluate trigonometric functions and stuff like that, I'm not going to ask you to come up with the coordinates necessarily, but what I will ask you is, okay, you know, you're in the middle of a problem and I'll be like, you know, so-and-so, what is the sine of pi over 4? Okay? You're like, sine of pi over 4. And you can like think to yourself, all right, well, the sine of pi over 4, right? If I think about pi over 4 on my coordinate plane here, you can think of it this way. Pi over 4, the sine, okay, was equal to the y coordinate at that point. So at pi over 4, the y coordinate is root 2 over 2. And so that's what sine of pi over 4 is, root 2 over 2. You can think of it that way. Yeah.
Isn't there like an easier way to do this by doing like special triangles on the other side there?
Yes, and we'll talk about that method tomorrow. We're going to talk about that method tomorrow. I'll show you that, okay? So yeah, I don't expect you guys to like every time, some people do this, you know, but yeah, tomorrow we'll talk about like kind of a, what I would say is my like, as efficient method as possible to solve these things. Right now we're just going to be using the unit circle to solve them, but yeah, tomorrow we'll, I'll show you kind of a more, an efficient way to do it too, okay? So yeah, but now we have our first quadrant there. Okay, and so then from that we can build the rest of our quadrants. We don't need to do nearly as much work to do those. So let me draw a 2-quadrant unit circle here. That's roughly all right. Okay, not great, but you get the idea. All right, and so we already had these points, 1, 0, and then, you know, at pi over 6 or 30 degrees, we had the coordinates root 3 over 2, 1/2, and then at pi over 4 or 45 degrees, it's going to be root 2 over 2, root 2 over 2. And then at pi over 3 or 60 degrees, it's going to be the 1/2 root 3 over 2. Okay, and then we have this point right here, which is 0, 1, which is the 90 degree or pi over 2. Okay. And we also have this guy over here, -1, 0, and that was 180. Or pi radians. Okay. So now for quadrant 2, right, our next angle that we kind of come across that's in quadrant 2 as we're rotating around here is the 120 degree angle or 2 pi over 3. Okay, now, how can you make a right triangle, right, from a 120 with a 120 degree angle in it, right? I mean, if you look here, right, if we're rotating from here up and around to the 120 degrees, how can you make a right triangle from that? The answer is you can't, and you don't. So then how do we evaluate this? How do we come up with coordinates for this when there's no right triangle to be made there? Well, you can't make the right triangle this way, but we can make the right triangle if we go this way. So 120 degrees counterclockwise from the x-axis is the same as how many degrees clockwise from the x-axis? 60, right? And so this is really, if from here around to here is 120, then from here up to here is 60, and it creates another 30, 60, 90 right triangle right there, okay? Which is identical, just a reflection of the previous 30, 60, 90 triangle that we did over here, okay? So what's going to be different? Well, the y-coordinate for this 30, 60, 90 triangle, the y-coordinate, that height there, was root 3 over 2. What should this height be? Root 3 over 2 as well, and it is. Okay? So the coordinate here does have a square root of 3 over 2. The x-coordinate here, right, the x-coordinate, we went out 1/2. In this case, the x-coordinate should be what? Negative 1/2, as we're going in the negative direction there. And that's the only difference. The x-coordinate is negative, the y-coordinate stays positive. And the same will be true as we continue around. Here for this angle, it's a 135 degree angle, or 3 pi over 4, which is really then 45 degrees back. So it's back to our 45 degree coordinates there, but it'll just be negative square root of 2 over 2, and then root 2 over 2. And then the last one here, 150 degrees, or, oops, I don't know why I'm putting it in parentheses there, or 5 pi over 6, okay? Again, that is the 30, 60, 90 triangle that we got used to get the 30 degrees or pi over 6 one, and so it'll just be negative root 3 over 2, and then 1/2. Okay? So what we do, we basically took that first quadrant and those coordinates and we just reflected them over the y-axis, right? The y-coordinates all stayed positive, but then their corresponding x-coordinates then just became negative because they're reflected. And then you can imagine taking this whole first and second quadrant and reflecting those over the x-axis, which will result in, well, what's going to happen then? We take this whole top half here and reflect it over the x-axis. What's going to happen to our coordinates here? The x-coordinates will stay the same, but what will happen? Yeah, James? The y-coordinates will be negative. Yeah, the opposite, right? So all these will reflect down then to get those other ones. And so, without filling in the rest of this, because that's good enough, I think, for now, we'll go to our special unit circle here, and we'll fill in those coordinates. Okay? So that was 1, so I'll kind of start back up there. So first quadrant, right, that point's 1, 0. And then this point right here, it's going to be the root 3 over 2, comma 1/2. And then here it's root 2 over 2, comma root 2 over 2. And then here it's 1/2 root 3 over 2. And then 0, 1. Came up with those coordinates, and again, I'll show you how we're going to use those coordinates here in just a second with like sine and cosine and evaluating them. Okay, so there's that quadrant, and then we can just do the same, but just reflect it. So then this point will now be negative 1/2 root 3 over 2, negative root 2 over 2, comma root 2 over 2, and then negative root 3 over 2, comma 1/2. Okay, please make sure you do copy this down, or you write this down accurately for your studying purposes. If you don't write it down accurately, then you're gonna run into trouble. Okay, and then we'll do the third quadrant, which will basically be all these points just reflected over the x-axis there. So now this point will still have negative root 3 over 2, right? The x-coordinate stays the same, but then the y-coordinate becomes negative 1/2. Okay. Here we had negative root 2 over 2, x-coordinate stays the same, but then the positive root 2 over 2 will now become negative root 2 over 2. And then finally negative 1/2 and negative root 3 over 2. And then this point right here is 0, negative 1. Oh, sorry, off the screen. And then quadrant 4, all the x values are positive, but the y values are now negative. So, positive 1/2, negative root 3 over 2. Positive root 2 over 2, negative root 2 over 2. And then positive root 3 over 2, negative 1/2. And there's the coordinates for the unit circle. Okay? So, the purpose of this, right, how we're going to use this today, what we're going to use this for, is to be able to quickly evaluate sine and cosine of any of these angles, okay, be they in radians or degrees. So how can we do that? Well, as a quick example, right, if I wanted to find the sine of pi over 6, or 30 degrees, I would go here, okay, and so I know that sine, right, if you remember back to our notes here, where we were doing the work here, I put it here, yeah, okay. When we take sine of that angle pi over 6, sine is opposite y over hypotenuse 1. Since we're on the unit circle, the hypotenuse is always 1, so sine of our angle is just the y-coordinate. Sine of the angle is the y-coordinate of the point. Okay? And so, if I want to know what sine of pi over 6 is, it's the y-coordinate of my point there, 1/2. All right? If I want to know what the cosine of 60 degrees is, or cosine of pi over 3, then I go to 60 degrees of pi over 3 on my unit circle. My hypotenuse is 1, right? The distance there is 1, and so it's just the x-coordinate, 1/2. So cosine of 60 or cosine of pi over 3 is 1/2. And so that goes to any of these points. If I want to find the sine of 300 degrees, I go around to 300 degrees on my unit circle. Sine is the y-coordinate, negative root 3 over 2. Okay. If I want to find the cosine of pi, here's pi. Cosine is the x-coordinate, negative 1. So cosine of pi is negative 1. It allows us to kind of quickly evaluate those trig functions using our special angles that are on the unit circle there. All right, so if you want to write that down, in fact, on your paper, x is equal to cosine of theta, and y is equal to the sine of theta. Okay, to help you remember how to evaluate those. X-coordinate is just the cosine of theta is just the x-coordinate at that point, and the y coordinate is the sine of theta, or sine of theta is equal to y. So you can use those to help you evaluate. Okay. So that's it. We'll talk later about tangent, and then the other three trig functions, secant, cosecant, and cotangent as well. But the good news is, if you can get down sine and cosine, then you're really going to be good to go with tangent. And then again, tomorrow I'll show you kind of like I don't say nitty gritty, but like, I don't know, a nice kind of procedure to go through to follow this, how to evaluate this, easily. If you're on your own, I've said evaluate a bunch of these. How should you go about doing this? I would not suggest regurgitating the unit circle. Oh, one other thing I want to point out: the unit circle, you will not need to be able to regurgitate this for any quiz. You will not need to memorize this entire thing with all the coordinates for any timed quiz or anything like that. Some people choose to do it that way. That's your choice. So you won't have to memorize this whole thing for any sort of timed quiz or anything like that. Okay, so, whew. All right, that was a lot, I know. So, to help you guys kind of relax a little bit, I've got a coloring activity for you, if you choose to color, that is. You don't have to color if you don't want to.
Does that mean there's no?
So,